All right, here we go. We're going to do 8.1 today. We're going to find the angle measures of a polygon. Our key vocabulary in this particular unit is going to be diagonal, convex, concave, interior angle, and exterior angle. All right, so let's just jump right in. We're talking about a polygon. If you remember the definition of a polygon from, when you learned probably in 6th, 7th, maybe in 5th grade, is that it has many sides, many angles, that kind of deal. Okay, so when we're talking about a polygon, we have a couple different types. We have a concave polygon and a convex polygon. A concave polygon is this right here. Here's our definition for concave. It's one or more vertices on the interior of the polygon. So if you look down here at this warped star, you're going to see that this is a concave polygon because this vertice is almost inverted, okay? But it is what we would call concave because it is on the interior of the polygon, okay? Those create what we call oblique angles, which we're not going to talk about in this particular unit. Instead, we're going to look more at the convex, okay? And convex, you'll notice the definition of convex has no vertices on the interior of the polygon. So concave, one or more vertices on the interior of the polygon. Convex, which we have here, all your vertices are basically jutted outward. Okay. I'm going to give you a second to write down convex. Okay. So, just keep in mind that we're going to be working primarily with convex, not concave. Okay, but just understand and have the vocabulary to understand that convex, just like in science, when you're talking about lenses, or if you want to be a eye doctor, you can talk about people's eyes are convex, concave, and that has to do with lenses and stuff like that, and how the light reflects off them. Anyhow, convex and concave. Okay, so we're going to be dealing with convex, not concave. All right. So let's start looking at our polygons. First, we can start with the triangle. Okay, I know that, again, this is mind-blowing for some of you that a triangle is actually a polygon, but it does have 3 sides and 3 angles. But let's look at that. So triangles, 3 sides, and the sum of the angles is 180 degrees. And we're going to go ahead and go up a couple polygons. Okay, if you look at the quadrilateral, it has 4 sides. Okay, obviously 4 angles. If I was to draw a diagonal through my polygon, or through my quadrilateral, okay, this is a diagonal. And a diagonal, for our definition purposes, is a segment that joins 2 non-consecutive vertices. So a segment that joins 2 non-consecutive vertices. Okay? That's what a diagonal is. So if you notice that there, what do you notice when you draw that diagonal? What do you now have? Well, now you have 2 triangles. If we go back to our original triangle, we know the sum of the angles in the original triangles is 180 degrees. I know that a lot of you already know what the sum of a quadrilateral is, but think about it in terms of a triangle. Okay, if you have 2 triangles, each equaling 180 degrees, what is the sum of quadrilateral angles? Yeah, it's 2 times 180 to equal 360 degrees. So drawing that diagonal creates 2 triangles, each of which is 180 degrees. So now our polygon, or our quadrilateral, is 360 degrees. Let's look at this pentagon. if I draw a couple diagonals connecting my vertices, what do you see now? Now you should see 3 triangles. So based on that information, what's the sum of a pentagon? This is 180, and this is 180, and this is 180. You have 3 times 180, and that's going to equal out to be 540 degrees. So the sum of the angles in a pentagon is 540 degrees. Let's look at one more polygon. And just for information purposes, you will need to memorize the names of polygons. So you have 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon, 9 is a nonagon, 10 is a decagon, 11 is an undecagon, and 12 is a dodecagon. Okay, I think that's probably as high as you need to go, but go ahead and start looking at those. And again, if you need to reference that, I know I went through those quickly, you can go back to the video, rewind it, or you can just look them up, just by name. Okay, so let's look at a hexagon. Let's draw some diagonals with our hexagon. Okay, how many triangles do we see there? Now you see 4 triangles. Of course, they're all equal to 180. And notice all my diagonals are coming out of the same vertice. I know I can draw more diagonals, but they're going to be overlapping, right? So I'm coming out of the same vertice to create my diagonals and to create my triangles. Okay, so now I have 6 sides. How many triangles? 4 triangles. And so with that being said, using that idea, how many degrees is my sum? We have 4 times 180, so that's going to equal to 720 degrees. Hopefully as you were taking these notes down and you were writing this down, you were starting to see a pattern develop. If you didn't, let me make it a little easier. I created a table here. Let's look at this table. In our triangle, we have 3 sides with 1 triangle and 180 degrees. Quadrilateral, you have 4 sides, 2 triangles, 360 degrees. Pentagon, you have 5 sides, 3 triangles, 540 degrees. Hexagon, 6 sides, 4 triangles, 720 degrees. So notice the sides are going up by 1, the triangles are going up by 1, and each time they go up, they're going up 180 degrees. Okay, but not 180 degrees per side. There's actually a formula to it, because obviously 180 plus 360 is 540, and then 540 plus 180 is 720. But you got to remember, we started with our polygons at 3. And so there's going to be, because we're not including 1 and 2 for sides, because those are not polygons, you're going to have a formula for that. Okay? So let's take a look. In order to find the sum of the interior angles of a polygon, it's going to be set equal to the number of sides minus 2. Okay? And we're minusing 2 because we didn't have 1 and 2, right? There's no one angle polygon or 2 angle polygon. So you're going to have the number of sides minus 2 times 180. And that's how you can figure out your sum. Okay, so if you have a 12-sided figure and you want to know the angle measure, you would simply take 12 minus 2 times 180. So if you have a dodecagon, you do 12 minus 2, which is 10, times 180. And the degree measure for a dodecagon, all dodecagons, is going to equal to 1800 degrees. So for every dodecagon, you're going to have 1800 degrees. If you want to do an undecagon, just another example, 11 minus 2 times 180. 11 minus 2 is 9 times 180. is going to equal out to 1620. So every 11-sided figure is going to have an angle measure of 1,620 degrees. All right? So let's take a look at another example. Okay, Canadian loonie. For those of you who don't know, a Canadian loonie is a form of their currency. It's a coin, and it has 11 sides. What is the sum of the interior angles? Okay, we just worked on that one, but let's do it again. So we take the number of sides, 11 minus 2 times 180. So then you'd have 9 times 180, and then you'd end up with 1620. So the total sum of the interior angles of a Canadian loonie is 1,620 degrees. Okay, what if we had to work backwards? It tells us, hey, the sum of the interior angles is 1,440 degrees. How many sides does it have? Well, that's pretty simple. Just set up an algebraic type equation. Now you have 1440 is equal to n minus 2 times 180. Okay? First thing I'm going to do to try to get n by itself is divide by 180. So 1440 divided by 180 is going to be 8. So then you have 8 is equal to n minus 2. Again, add 2 to both sides to get n by itself. And now you're going to have 10 is equal to n, and n is the number of sides. So what kind of shape do I have? Yeah, this is a decagon. All right? So that's how you can use that formula forward and backwards in order to figure out the number of sides or to figure out the sum of the interior angles. What about this example here? Here we have, what kind of shape is this? Whoops. Okay, we have 1, 2, 3, 4, 5 sides. Okay, so we have a pentagon. So the first thing we need to do is figure out how many degree measures, what's the sum of the angle, the sum of the interior angles. We need to figure out that first. We're not going to go back to our table. I know we can, but let's go ahead and figure that out. So we're going to do n minus 2 times 180 to figure out how many degrees it should have. We said it had 5 sides, so 5 minus 2 times 180. So then you end up with 3 times 180. And 180 times 3 is 540, which matches our table from before. So this polygon should have 540 degrees. So from this point here, all we have to do is add up the sides. So 110 plus 92. Okay. Plus 100. Plus 84. So it has 386, so now you have 386 plus x should equal to 540 degrees. So subtract 386 from both sides and you end up with 154 degrees. So x is equal to 154. All right, moving forward. Hey, now we're going to talk about regular polygons. And regular polygons are significant because regular polygons are where all parts are congruent. Okay? That means their angles and their sides are all congruent. And it's important to understand that because when you have a regular polygon, now you have the exterior angle sum is equal to 360 degrees. So all parts are congruent and the exterior angles are equal to 360 degrees, and we're going to talk about that in order to help us with another formula that we're about to get in just a second. So I'm looking at this regular polygon, which is a square, okay? I know that this angle right here is 90 degrees. Well, its exterior angle right here is also 90 degrees. 90, 90, 90, 90, 90, and 90. Okay? So all those are 90 degrees. So if you have four angles at 90 degrees, 4 times 90 is going to give you 360 degrees. So these exterior angles here all equal 360 degrees. If I took a triangle and did the same thing, and I'm not going to go into major detail with this because I'm not going to be able to draw a perfect triangle, but if I had a triangle and I did the same thing, all parts are congruent. I know that this is 60, right? And if that's 60, that means this is 120. And over here, again, because we have an equilateral triangle where they're all congruent, that's 60. That means this is 120. And then one more time over here. That's 60 in there, so the exterior angle must be 120. And I'm getting that because they're supplementary pairs or linear pairs, right? And so now I have 120 times 3. So 3 times 120 is going to equal 360. So the exterior angles sum is always equal to 360 on regular polygons. Okay? So that leads us to another formula. One interior angle is equal to n minus 2, the number of sides, minus 2 times 180 over the number of sides. Okay? Now watch this. Before you freak out and say, oh, this is stupid, this is not good, watch for just a second. So, let's start with the number of sides. We just did an example of a triangle. So we're going to try to find the exterior angle, the interior angle of a triangle, which we already know the answer, but I just want to show you how this works. So 3 times the sides. So 3 is n, 3 minus 2, because 3 sides times 180 divided by 3. Okay? Well, x is equal to 1 times 180 over 3. So 180 divided by 3, the interior angle is 60 degrees. Okay? On the other side of that, what if we started with the exterior angle being 60 degrees and we said, okay, we need to know how many sides this figure has. So now we have 60 equals n minus 2 times 180 over n. So we could solve this algebraically as well. So now you have 60n is equal to n minus 2 times 180. Now I'm going to have to distribute. This one's a little more challenging from this aspect. So now you have 180n minus 360. Okay? I'm going to put the 360 over here and subtract the 60 from the other side. I'm going to have 120n. And now divide both sides by 120. And n is equal to 3. So that's how you use the formula as it is. Now, with that being said, this example right here, or this particular use of the formula, is kind of a pain, right? So, what you can do to make this a little bit easier is to modify this particular formula to where you're going to end up doing 180 degrees minus the interior angle equals the exterior angle. Okay, and what that's going to do is that's going to allow you to have a proportion, okay? And so what that allows you to do is basically say, okay, 180 minus, I was given 60, right? So minus 60 is equal to the exterior angles, which is supposed to be 360, right? Excuse me, not 360, 120, right? Okay, because the interior angle is 60, the exterior is 120. Okay, now using that, what you can do is take 360 and divide it by the exterior angle, which is going to be 3. Okay, let me go back to that one more time for those of you guys who didn't catch that. So here's our little shortcut idea. We know that 180 minus the interior angle is going to equal our exterior angle. Okay? Well, if I have 180 minus 60 on this particular example over here, that equals 120. Now what you do is you take that exterior angle and you divide it into 360 because the sum of all exterior angles is always 360. So 360 divided by 120 is going to give you your 3 sides. So you can do that every time. So for example, if we do this problem right here, it says the interior angle of a regular polygon is 135. How many sides does it have? Well, take 180 minus our interior angle, which is 135, and that's going to give us our exterior angle, and that's going to be 45 degrees. Okay, so what you end up doing is doing 360 divided by 45, which is going to give you 8. It's going to be 8 sides. So you can do it that way, or you can go back here and say, okay, let me use the formula just to prove that this works. Let's use the formula. So we could use the formula and just say, all right, based on the formula that I have memorized, I know that one interior angle is 135, and that equals n minus 2 times 180 over n. So then I know 135n is equal to 180n minus 360. See how it's always turning out the same up there on top? Okay. And then I switch sides and I end up with 45n is equal to 360. Divide both sides by 45. N is equal to 8. You see how essentially this step is the same as this step? We just did a shortcut to get there. All right, and that's pretty much it for this section. So you'll be cut loose to do your homework, your classwork, and make sure you have good notes on this. Always refer back to your notes when doing your homework. If you have any questions, please come see me.